So we're going to let row 1 stay. Oh no, that's going to die. And we're going to make row 2. We're going to use row 1 to get zeros in column 1. So I need to do -2 times that plus 2 to get my 0. So row 2 is going to become -2 times row 1 plus row 2. So -2 plus 2 is 0, like I planned. 2 plus 1 is 3. -4 minus 1 is -5. 6 plus 0 is 6. See how I did? Awesome. And so now I'm going to change row 3 to get the 0 there. And all I have to do is, again, you're using row 1 to get zeros in column 1. So use row 1 again and just add those two together. So 1 minus 1 is 0. Oh, so sorry, row 3 is going to become row 1 plus row 3. So 1 minus 1 is 0. -1 plus 2 is 1. 2 minus 3 is -1. -3 plus 7 is 4. Check. Zeros in column 1. So now, for our next one, row 1 and row 2 are going to stay the same. And then we're going to use row 2 to get zeros in column 2. So I'm going to go for this 0 now to get this lower triangle of zeros is what I'm going for. If I wanted to go all out, I could get a 0 up there and zeros there and there and get a bottom triangle of zeros and an upper triangle of zeros, do the full Gauss-Jordan elimination, but I don't want to. Just this lower triangle will do. So I need to use the second row to get zeros in the second column. Now, so even though if you add -1 and 1 and you get 0 and you're like, yeah, I want to do that, if you do that, you'll lose this 0 that you worked so hard to get. So don't do that. Use row 2. So I'm going to have to, it's fine. So I'm going to go ahead and multiply -3 times row 3 plus row 2 to get my 0 there. Now, some teachers might make you multiply this by 1/3 and actually use that one and not manipulate that one for like simple row echelon, there's a fancy word that's not coming to mind right now. So, but it still works. I mean, this is an equation, that's an equation. You're manipulating these just as you would if you were doing straight up substitution or elimination. It's just we're doing it in a matrix that's supposed to kind of streamline things so we don't have to write x, y's, and z's. But everything you could do if you were doing elimination, you can do here. It's no big. So, alright, so we're going to do -3 times row 3 plus row 2. So -3 times 0 plus 0, that stays 0 like we needed it to. -3 plus 3 is 0 like we wanted. 3 minus 5 is -2. -12 plus 6 is -6. How'd I do? Awesome. Alright, so now I've got this little lower triangle of zeros, and I can rip this thing out of the matrix. I'm done with it. So remember, this is my x's, my y's, and my z's. So this means that -2z equals -6. So that means that z equals 3. I got one. And so now we're going to go ahead and do what they call back substitution and hopscotch up here and say that 3y minus 5z equals 6. And then plug in the 3 for the z. So this will be 3y minus 5 times 3 is 15 equals 6. So 3y is 21, so y is 7. Excellent. Now hopscotch up to the last equation, and you've got x minus y plus 2 equals -3. So x minus 7 plus 2, oh sorry, this is 2z. So 2 times 3 is 6 equals -3, so that's x minus 1 equals -3, so x equals -2. Yes, I can add. Alright, so my answer should be -2, 7, and 3. And again, you can check these by plugging them into every single one of your original equations, and it should make all of them true. It's kind of amazing. We found x and y and z such that it satisfies all those.